Hey, welcome back to another video. It's me, back again. I'm doing just fine. I appreciate some people reaching out since I didn't release a video this past weekend, but everything's fine. I just need to plan some of these things out. So this past weekend, I kind of prototyped out the idea for the next few videos that I'm going to do. As you may have realized, I don't have all of this planned out in advance. A lot of this I'm just freestyling and responding to different comments and questions that are on the Buy Me a Coffee page, on the YouTube comments, and on the discussion board. And I try to incorporate those ideas into the video, and sometimes it takes me a while to kind of put them together into something that forms a tutorial or a lesson where we build a concrete project. And so that's why it's taken me a couple days to plan this one out, but I have some good material coming. So the next 3 videos, we're going to be discussing backtesting our strategies, and I'll tell you why in a minute. First of all, I miss you. We haven't talked in a while. So what's happened since the last video? Well, you'll see the Dow Jones Industrial Average closed above 30,000 for the first time. So it's been on the hat this whole time, so I hope you bought some stocks. Tried to tell you. Anyway, yeah, we've had quite the move recently, including in some of the stocks we've been discussing during just this tutorial, including Dolby. At the beginning of the series, we're discussing this pattern and the possible breakout in Dolby stock, and you'll see how it ran from the high 60s or low 70s to about $90 a share. Had a very explosive move, so I hope you caught some of that. And also, we talked about NIO in the last video. We talked about entering this trade here and putting in a trailing stop to avoid this huge drawdown here so that we protected some gains. It also gave you another opportunity after that video. If you traded this stock again, it made another move from about $40 a share all the way up to about 60, in which case you could have set another trailing stop and caught another gain there. So that was another great trade in a hot stock with a lot of momentum. But as you know, this channel really isn't about giving stock picks. It's about Python programming. So that's what we're going to talk about in this video. So before I get started with the Python programming, I'm going to highlight a few comments that I've received on the Buy Me a Coffee page and also on Twitter and YouTube, and address those because they will form the subject of the next several videos. The first comment here, I want to thank again Jay Sniper, who has contributed once again with the 5 drinks. Cheers, Jay. And just so you know, I have not only drank all of this money, I appreciate the donations. I actually do have a Raspberry Pi here that I'm going to be using in a future series where I'm going to attempt to make a little server that I host at my house. And if you get one of these Raspberry Pis, we'll talk about how to set one of these up. I've never actually done this, so it'll be a fun little project to do for the holidays. And it'll be, instead of, if you don't want to rent a server, then maybe you want to try one of these. I think they're like $50. And then you can put it in the corner of your house, and it can just run your trading bot all day. And so that'll be the project we do closer to the holiday, to the Christmas time. And also recently I got this Galaxy Tab, which is really cool. I've been playing with this, and I'm going to use this to kind of draw on the screen and use it when I'm illustrating a point. I need to figure out how to hook it up to my MacBook first, but I know it hooks up to TVs and things like that. So this is another cool piece of gear that I'm going to try to incorporate into the videos. So I'm not just blowing it all on alcohol and whiskey. Just so you know, I'm actually reinvesting some of this money back into the channel. So I appreciate all of the contributions. So thanks once again, Jay, for the contribution. And Jay has also asked if you're going to make this trading bot available online. And yes, I am. As I mentioned earlier in the series, I'm going to be deploying the web app and the bot to a Linode server. So in the cloud where it can run, outside, not just be running on my laptop right here. So I'm going to do that at the end of the series. The thing is, I keep adding on new stuff, like these 3 videos I'm about to do on backtesting weren't even part of the series. I'm only doing this because there's another comment here asking about backtesting. And so I'm adding that in, and then I'll eventually get to the rest of the topics, including deployment. And then Jay also asked about streaming data to the database. I'm going to do that in this video and handing off those calculations to the trading bot. So I'm not going to really have 2 processes running in parallel. But what I am going to do in this video is insert minute data into the SQLite database. And then if you want, the trading bot that's running on the cron can actually read this data. So yeah, we can have one process write data to the database, in intraday data to the database, and perform some calculations. And then we can have another process that just reads data instead of having the trading bot fetch data from a REST API, which can take some time and then also has to do calculations. You're right. Now, the calculations I'm doing so far, I don't think are very complicated because it's just like, measuring candlesticks and computing Bollinger Bands, and those are very, very easy statistics that can be calculated by a simple Python script. But I could see where if you're running some type of machine learning model or something more expensive, then maybe you want one process to handle those expensive calculations, and then another process to just read some data and execute an order to the broker. And it sounds like Jay is also interested in arbitrage and crypto. And so, yeah, as you've seen, crypto has had a huge run. Bitcoin's almost 20,000 again right now, going to all-time highs, which we've been talking about since around the TTM squeeze video. We were talking about how Bitcoin was kind of trading in that tight range and about to take off. So that's happened now. So yeah, I hope you made some money buying some crypto. Hopefully those Binance videos were helpful as well. Jay is also asking a bit about different crypto exchanges and arbitrage opportunities. And as I understand it, I've never actually done this, but as I understand it, years ago, this was very easy to do. I'm sure it's harder to do now, where you can just like buy on one exchange and then sell on another exchange for an immediate profit. I would have to look. I actually haven't tried all the different exchanges before. I'm mostly a stock guy, as you know. So yeah, maybe there's some opportunities there. And speaking of storing intraday data, Banu here on Twitter was asking if I could go over storing intraday OHLC data in a database and keep the database link the same and delete old candle data. And that's actually what I'm going to do in this video. Is I'm going to take that Polygon data for the backtest that I'm going to write. And so I'm going to take all the old minute data. That way we can actually backtest, does this opening range breakout strategy even work? All right, next comment. Thanks to Flashman for the contribution. Flashman actually emailed me privately with some additional information, so I appreciate the contribution. Flashman actually is in London and worked in the hedge fund industry and now does a lot of work in data science and consulting for finance and is a fan of the channel, but he mentioned there's a few topics that I haven't discussed yet that I should cover. And the first of those is machine learning. And the reason I haven't talked much about machine learning, even though a lot of people are applying it to the markets, is that I am not a machine learning expert, right? And so I've taken a couple classes at UC Berkeley here in person in the Bay Area on machine learning with Spark and also on data science with R. And I also did this Coursera machine learning thing through Coursera, through University of Washington, I believe. And so I have a little bit of experience. I know some terms, but I actually haven't done a lot of work in applying this to the market yet, but that's something I'm willing to learn and share what I learn on the channel. So I'm hoping to get to that very soon. And I actually reached out and discussed this with a Python engineer here who lives in Berlin. And this guy, Patrick, is he knows a lot more about machine learning than I do. And he actually runs a YouTube channel that has about double the number of subscribers that I do. And he talks a lot about PyTorch and TensorFlow and many different machine learning topics. And I actually messaged him on Twitter to discuss a possible collaboration. And it seems he's interested in doing that. And so we're going to probably do that in December, and so we're dividing up what that would look like now if we had like two different people from different channels putting together a tutorial. Since he's not a finance guy, I can talk a little bit about the markets and prepare some data, and then he can apply some machine learning models to it, and then we'll put it all together and see, how well does it work? Is it effective? Does it enhance our trading strategy, and so forth? So that's the other thing I was doing this weekend, was playing that out a bit and planning out what we're going to do the rest of the year. So I look forward to the possibility of applying machine learning in some of these videos. So thank you very much, Flashman. And also, Flashman, and I'm sorry, I'm sharing a bunch of stuff, but I really enjoy these personal comments and, having a conversation with people and their different experiences. And so Flashman, since he has some background, also shared with me this PDF. So since I was discussing opening range breakout, he actually had the original source material or the book that this strategy came out of. So it's this day trading with short-term price patterns and opening range breakout. And this is an old book from 1990, it looks like. So this is like 30 years old. And so this goes a lot more into the different patterns that were studied. And apparently this was written by a successful trader in the 80s and 90s. And so that's all the more reason why we need to backtest this strategy, right? Because sure, maybe this worked well a long time ago, but maybe in the current market, maybe this opening range breakout strategy isn't even, maybe it's not even profitable. After all, we just took this from a blog article, right? Someone mentioned to me on Twitter, can you cover this opening range breakout trading strategy? And I looked at it, made sense, and decided to code it up and run it. You know, some of the trades were profitable and some were not. But, you know, how do we really know if any of these ideas are actually profitable unless we go through and backtest them, right? And not that a backtest, you know, just because a backtest works well doesn't mean the strategy is perfect. But if someone's recommending something based on past experiences, right, it means it must have worked in the past. So we should be able to test someone's claims that this worked. And that's what the topic of these next few videos is about. All right, so thank you to Flashman once again for contributing in multiple ways, both in suggestions and also contributing this original source material that's based on you know, real-world experience and things he already knew about. Also, thank you to other contributors who didn't leave a comment, but thank you to Jitinder again. I believe he's already contributed in the past, and also thank you to Corey Pettijohn for your contributions as well. And then the last person I will thank here is Time, who left a comment that made me add backtesting to this series. Time says, content's great, and thanks for your time, but not sure if you had this planned already or not, but could you integrate a backtester into the full stack trading app? It would be great to backtest our strategies in the same app and send them live. And yep, this gave me the motivation, especially since he bought me 20 drinks, right? Well, how can I not do it now? So thank you, Time, for the contribution and the 20 drinks. And so, yeah, that's going to go a long way while I'm in quarantine. And so I appreciate that. And that's why we're going to be backtesting this strategy to see how well did it actually even work in the past few years. Did it work at all? And we're going to be using Backtrader, which is a backtesting framework that I've covered earlier in the channel. I have a couple different videos where I use Backtrader, and I'll review how to use it again in these next few videos. And so, yeah, let's go ahead and get to coding. So in part one of this, there's like a little sub-series inside of this series. So in the first part here, I'm gonna actually get the data, the historical data, the historical minute data, right? Right now we just have historical daily data, but since we're doing an opening range breakout strategy that relies on intraday data and each minute by minute to make our entry, we need historical minute data in order to backtest the strategy. And so what we'll do in this video is prepare all the data and go for all of the companies I'm just going to do the NASDAQ 100, get all 100 companies in the QQQ, and store minute data for all those for the past year. You can store more than that if you want, but if you go through like 10,000 stocks that we have in our database and store minute data for the past 30 years, that's going to be a shit ton of data. And so so that this finishes on time, I'm just going to do 100 stocks for a year of minute data. And I think that's several gigabytes of data. I looked at the SQLite database after I did this. So the more of this minute data that you store, the more disk space it's going to take up, which might be why Banu asked, can you trim the data? So what we can do is store the data, and then each time a new day, each time we need to store new minute data for a new day, we can get the minimum old day and delete all of that data from the database in order to keep it roughly the same size. So yeah, first video, I'm going to show you how to write a script to download all the historical data, and we're going to store it in a new table. Second video, the one after this, I'm going to write a Backtrader backtest, and it's going to run through a backtest for every single stock symbol that we have minute data for. So all 100 of those symbols, and it's going to trade them for every single day for the entire year. And it's going to show you the results, like how much money was made or lost by trading each of those stocks. And we can see if maybe it was better to trade certain stocks than others. Like, is there certain characteristics of some stocks that cause them to perform better using this particular strategy? And then the third video, we're going to talk about optimization. So Backtrader actually has the ability to fiddle with the different parameters and tweak them. And so we talked about using, this article mentions using a 15-minute opening range, right? But it also mentions that some people use half hour, some people use 1 hour. There's different definitions of opening range, right? And so how do we even know which one to use? What Backtrader allows us to do is we can run this optimize strategy function, right? And say, try out these different parameters and compare the results against each other. And we can see which time frame, for instance, worked the best. Or, if we combine it with other strategies, we can send it, many different permutations of parameters and see what would have performed the best, right? So that's what I'm going to cover in the third video after we run the initial backtest. So let's go ahead and get started with just downloading the historical data, get that part done first. So let's get into it. All right, first we need a list of stock symbols that we're going to fetch data for. Now we already have a stock table with over 10,000 stocks, right? But as I mentioned earlier, we're not going to fetch minute data for all of them. And the reason for that is I don't want to test every stock, first of all, but also it actually takes up a lot of space. I'm actually going to download minute data for the whole year. And so I'm just going to do it for 100 stocks. So these stocks that are part of QQQ. And so in the GitHub repository, I have this full stack trading app repository, which I have not put all the code in yet, but I added this qqq.csv here that you can use for this exercise. If you click on raw here, you have the CSV file of all the stocks in QQQ. And so I can go to my full stack app and I'll just create qqq.csv and I'll paste this in, and it's just the name of the company and the stock symbol. And so these are all the ones we're going to do. It looks like it's 103 actually. Okay. The next thing we need to do is create a table in which we will store the minute data. Now we already have this app.db here that has a table for stock, stock price for daily closes, stock strategy, and strategy. So since I'm only using this data right now for backtesting and I'm not displaying this minute data on the UI, it's just history that we can use in a backtesting program, I'm going to just create a new table for stock minute data. And so I'll do that now. So what we need to do is create a new table. And I have this query written now. So what we can do is write a create table statement. So I have the database open and I'm executing another create table statement. And this is very similar to the other create table statements. We already have this one for create stock price. And so I can actually put it after here too, so that if we want to create the whole database again, we can put it in here. So I'll do cursor.execute if you've been following along, and I'll paste that here. And so it's the same thing pretty much, except I'm calling this one stock price minute. We have an ID, which is just a primary key that auto increments, just makes each record, creates a unique ID for every record in this table. It references a stock ID, has a date, time, open, high, and low, and close. The date, so here we actually just have a date, but in this table we have a date time. So we're going to store like November 20th, 2020 and 11:45 a.m. in there. Open, high, low, and close for that minute, the volume, and we have our foreign key reference defined here. So that's all we need for this table. And so I can just execute this inside of SQLite, or if I'm creating this brand new, I can execute this create_db.py. And so I'll execute this now. Okay. And then now I can go back to the database structure. Now that I've done that, you'll see there's 5 tables. There's one called stock price minute. And in my browser, I should see this other table that is now empty. And so we're going to change that by populating this table now. So we're going to write one script that loops through each symbol in this QQQ list and then finds the reference to the stock ID in the stock table, right? So that we have the reference in our database, and then it inserts open, high, low, close data that we fetch from Alpaca and Polygon using existing code we already have. So we're going to loop through that data. So let's do that now. So what I'll do here in my Visual Studio Code, now that I have the table created, let's just create a script again. And so I will create a script called populate minute data.py. As you can see, this is not very well organized now. You could actually organize all these scripts into folders and modules. I'm just creating individual scripts in this one directory, other than the templates that I've kept separately here. So I have this populate minute data script here, and I'm going to import some of our existing code. So I'm going to import config, since that has the path to our SQLite database. I'm going to import SQLite 3 because we're going to be connecting to our SQLite database. I'm going to import pandas, since we'll be working with pandas data frames and we might need to do some manipulations. I'm going to import CSV, since I'm going to read this CSV file to decide which stocks that I actually want to populate. I'm going to import Alpaca Trade API as Trade API. And also I'm going to import a couple of date time functions because I'm going to do some date time manipulation. So I'm going to do from date time import date time and time delta. And I'll talk about why I need this time delta in a minute. Okay. The first thing we'll do is we'll connect to our SQLite database. So I'll just do connection equals SQLite3.connect, and we have our config.db file, and our db file is just the path to this app.db. And so then we have a connection, and then I'll create my connection cursor. So I'll do cursor equals connection.cursor. And I'll also add this row factory that we've been adding. So connection.row factory equals SQLite3.row. And this just makes it a little bit easier to access our rows that we fetch, and it lets us access each of the columns more like a dictionary key. And this is easier than just, by default, SQLite3 will return a list of tuples. And so accessing those tuples, doing it by numeric indexes is a little bit harder than accessing it by column names. Okay, so I got a cursor object, right? And then now we need to call the Alpaca REST API. So I'll do API equals Alpaca, or equals trade API dot REST. And this requires an API key, which we already have defined in our config file here. We have config.api secret. So secret key and config.api URL. Okay, so we have those already. And so what we're going to be doing for each symbol is calling api.polygon, which we've already done in the other videos, .historicAg v2. And this just requires a symbol. And then we give it a time frame. So we want the 1 minute time frame. So we're going to do 1 and minute. And we're going to do from equals some date. So I'll do I'll do the 1st of 2020, and I'll do 2 equals 2020 11/20, which was on Friday. Okay, so if I do that, and I'll give it a symbol, so I'll do Apple, and I'm just testing that this thing actually works. And then you do a .df here to access that data as a data frame. Okay, so I'll assign this result to a variable. So I'll just say minutes equals API. Okay, so that should return all the minute data for Apple for this year into this minutes variable as a data frame. And so if I print minutes, let's just see if this works, and we'll keep modifying it until it does what we want. Okay, so I'm going to test that out, run it, and look, looks like it worked the first time, which is great. So you can see we have a timestamp, January 2nd, starting first thing in the morning in the pre-market. We have open, high, low, close. We have more minute data, and so forth. And you see there's gaps in the minute data since this is pre-market data, so there's not always minutes where the stock traded, right? Okay, so that's looking pretty good, but you'll notice the last line of this is January 10th, right? And even though I asked to get me data through November 20th. And so the reason that stopped is this will only give you a certain number of days at a time. So I think it might give you like a week or a certain number of bars. Since we're accessing minute data, there's a lot of bars in a single day. And so this stops at January 10th. And so what we'll want to do here is actually page through all the dates. And that's why I imported this time delta. So we'll just import the data week by week. So we'll be like, we'll say, give me all the minute data from January 1st to January 7th. Add 7 days to January 1st and gets all the minute data from January 8th through January 14th, and keep adding weeks, and we'll iterate over all of the weeks, get all the minute data. That way we'll build this database with multiple requests, since it won't give us all of the data at once. So when looking at shorter time frame data, especially stocks that are thinly traded that aren't as popular as a stock like Apple, the stocks with less volume, you'll notice every once in a while there will be minute data there will be some minutes that are missing in this minute data. For instance, this is before the open, but you see right here, 9:12 a.m. till 9:14, you'll see there's a minute missing there. If that minute was missing during normal market hours, when we're applying our opening range breakout, for instance, right? We're applying that strategy from 9:30 a.m. through 9:45 a.m. So if the minute for 9:37 was missing, what do we do in that case, right? We don't have the price data. Let's say no shares traded in that time. Do we do an average of these two different prices for 9:36 and 9:38 to fill it in? No, because that is using information from the future. So what you actually want to do for this missing minute data, you don't want to leave it blank, right? You don't want that gap because you might be counting like 15 bars at the beginning of the day. You want to fill it in with some type of value. So you want to do is actually forward fill the previous minute. So whatever the price data was for 9:36, you would fill it in for 9:37. So we could find cases probably if we look through the minute data for XLNX where there's a specific piece of minute data missing. And so what we want to do is do a forward fill. And that's one of the benefits of using a pandas data frame here is that we can use this ffill function. So I'll pull that up here just so you see what I'm talking about. Ffill in pandas. Okay. And what that will do is fill in gaps since pandas has some awareness of our index, which we're indexed on the date time. We can do this ffill, and an object with missing values will be filled or none, right? So you can do things like fill empties with zeros, you can fill it with none, or you can fill it with a value, which we're going to do in this case. And so what I'm going to do here is do minutes equals minutes dot resample 1 minute. And so pandas is aware that this data is stored in minute increments. And I'm going to say resample 1 minute ffill here. Okay, and let's look at some data that we're going to test to see what this does. And so if you look on January 21st here, you'll see there's these gaps, right? From 924 to 927 and 928 and 929, right? And so if I run it now with that forward fill, let's see what it looks like for January 21st. Okay, so that ran. And so if you look at 928 here and 930 and 927, you'll see this forward filling happened to fill in the price data into the minute 929, and the prices match what was at 928. So if there was no trades that happened in that time, the price is just the same as it was the previous minute. And if you scroll up here, you see we have all of these gaps in our data are forward filled, and we don't have any problems with missing minute bars. So that handles that. So the next thing we want to do is loop through all of these minutes, right? So I can do for index, comma, row in minutes dot iter rows. Okay, so we're iterating over the rows in the pandas data frame. The index here for the pandas data frame is this timestamp, and then we have all of the row data. So if I print index and I print row, we should see some data here. And so let's loop through it line by line so that you see what that looks like, what the structure looks like. Okay, so I'm looping through that. You see it's basically the same thing, but you see that we have each row line by line. So the row has an open, high, low, close, and you see the index is the timestamp here. And so what we'll do for each of these rows, we're going to insert a record into the SQLite database. And so we can do cursor.execute. And earlier in the series, you see how this is all building upon each video builds upon the previous ones. And so if you learned the part about databases, now you can run a SQL insert statement. So I can do insert into stock price minute. So we're going to insert into a table called stock price minute. And the columns we need are stock ID, date, time, open, high, low, close, and volume. Okay, so we're inserting into those columns, and we're inserting some values. And we have 1, 2, 3, 4, 5, 6, 7 columns we're inserting into. And so we'll have these 7 placeholders. 6, 7, just like that. and then we're going to insert some parameters. And so for those placeholders, we need 7 values in a tuple here. And so we're going to need the stock ID, right? And I don't know what that is yet. I'm going to type 1, 2, 3, and we're going to fill that in with some dynamic code in a moment. So I'm going to insert a stock ID. We're going to need a date time, which is actually the index here. So for the date time, you see how it has a -5, and we've seen in the past how it has a -4 sometimes. But the New York Stock Exchange always opens at 9:30, right? So I'm just going to store it in the New York time and get rid of all these offsets that change back and forth. Okay, and so I can localize that timestamp. So I'm gonna use index.tz_localize none, and I'll post this script right after this so that you don't have to copy that. And I'm gonna do .iso format, and that'll store our timestamp in the proper format that we need, right? And then I'm gonna do row open. So each of these is a row, and we can access each attribute as a key. So I'll do row open, row high, row low, row close, and row volume. Okay, and that'll be that. And so that is an example of one insert. And I could run this real quick. Yeah, why don't we run this real quick just to make sure it works. So I'm gonna do connection.commit at the very end here after the loop is done. And let's see if that works. Let's just make sure this works for 1, and then make sure it works for 1 range of dates, and then we can run it for all symbols and all dates. Okay, so it says no such table stock price minute. And why is that? Because I ran the query inside of the SQLite browser. It actually doesn't commit any of the changes until you do close databases and save, or until you just do save. So I didn't write the changes and commit them to the database. And then I'm committing any changes here in the script at the end by just calling connection commit. So I'm going to run this one more time, and it should have that table in the database now. Okay, so I'm going to run this through. And I didn't need to print all these rows and indexes again. It looks like it slows it down a little bit, but they're printed out now, and I'll just wait for this to finish. And it's done. And now I'll go to my SQLite database, open it up. And if I open up my AppDB and I go to stock price minute, you'll see we have all of this minute data that is stored, and volume data and so forth. If I scroll down, when you see the volume start to increase, that should correspond to the opening of the market at 9:30. So if I get to right here for that stock, right, you'll see a lot of volume. It's very thin, a lot of volume. If you look, that's indeed 9:30. And so we're always going to look at the time 9:30 to 9:45 when we're testing this opening range breakout strategy, and it'll be in a nice consistent format on our timestamp, right? And so now what we need to solve next, the stock ID is obviously not 1, 2, 3. We need to use the stock IDs that correspond to the actual stocks in our stock table. Okay, so what we'll do now, since I have this QQQ CSV, I'm going to look up all those symbols and get their stock IDs. And I'll comment out this part that's inserting records for a second. And I'll also delete these records from the database real quick. So I'll do delete from stock price minute, because I just wanted to see that this worked, but that's not the correct data. So I'm going to do that, and I'm going to save. Let's see if I just save. Yeah, so I'll just save that. Okay, and so now we're starting with an empty database again. And I'm going to comment this out for a bit. And I'm just going to comment that out, and I'm just going to do pass. And when I feel ready, then we'll run it through for every single stock. Okay, so I'm already getting all the minute data. And so let's parse that CSV file, the QQQ CSV file, and look up all the symbols real quick, right? And the data that comes back from Polygon or Alpaca it just has the symbols. It has no awareness of our stock IDs. So we need to look this up in our table. So we'll get each symbol, look it up in our table. We'll build a dictionary that maps a symbol to a stock ID. That way, as we're looping through, we can just access the key in the dictionary, and that'll give us the ID of the stock, and we can insert it in as we're looping through all of the stock symbols. Okay, so at the top here, let's see, where should I put this? I'll just put this above the database connection here. I'll create a new list called symbols, and then a new dictionary called stocks. And stocks will have like a symbol as the key, and then as the value of that dictionary key, we'll use the stock ID. Okay. We already have, okay, so I need a connection to the database, so I'll put this code after the database connection. Okay. And then what I'm going to do is do with open qqq.csv. So I'm going to open the CSV file as F, and then I have a reference to the file in F. I'll do reader equals csv.reader F, right? So we have a way to read a CSV file, and then I can do for line in reader. Let's just print line, see what that looks like. So print that out and run it. All right, so you see that gives me, I'm looping through a list of lists here, and the 0th index is the company name, and the first index of each list is the stock symbol. And so all we got to do, we can build a symbol list real quick, right? And so I'll do, since I start with an empty symbol list, I can do symbols.append line 1, and that'll give me my list of symbols. Okay, and let's do that. So now I should be able to print symbols after this is all said and done, and I should just have a list of symbols. Great, I have a list of symbols. So now that we have a list of all of our symbols, let's go ahead and map all of those symbols to stock IDs. So what I'll do here is query the database, and I'll just get a list of all of the stock IDs. So I'll just do select star from stock so that we can pull them in. So I'll get all of the stocks from the table, and then I'll do stocks equals cursor.fetch all. And I notice I called this dictionary stocks. I'll call it stock IDs. So stock IDs equals an empty dictionary. And then I'll do for stock and stocks. We'll loop through all of these stock rows, and then we'll say symbol equals stock symbol, right? So this is the stock row, and this the name of the column we're looking at is called symbol, and we'll just store that in symbol. And then I'll say stock IDs symbol. So that would be stock IDs in a dictionary, and this would be a key like Apple equals stock ID. Okay, and so if we print this dictionary now after all of this, then we have a nice dictionary for looking up a symbol and finding the appropriate stock ID. And we also have a nice list of symbols that are in QQQ. And so all we need to do is loop through all of the symbols in QQQ, right? So I could do for symbol in symbols. And for each of those symbols, we'll call this same code that fetches the minute bars for each of those symbols. So we're calling this code over and over again to fetch the minute bars, and then we're going to loop through all the minute bars and insert stock price minute records for each of those stocks, and we have a way to look up the stock ID, right? So that's looking pretty good. So I'm going to indent this out here since it's inside of this loop. So we're looping through all of the symbols, okay? And the next thing we need to do, you'll remember that it doesn't return all of the dates at once. So since we have this date range of January 1st through November 20th, we want to just do this 1 week at a time. And so we need to just fetch each week and loop through each week and fetch the minute bars, because it won't give us a big dump of all the minute data for years and years. We can only do a certain number of we can only get a certain number of minute bars in a single request, because otherwise the data response is just too big. And so what I'll do here, for each symbol, we're going to start over with a new date range. So we'll start over at January 1st, and I'm going to say start date equals date time. So I'm going to create a date time object, and I'm going to start this, I'm just going to start at January 6th. You can start a different date if you want to. This is like the first full week of the year, right? I'll do a datetime object.date. So we'll start at January 1st, right? And I'll comment this out real quick just so you can see what I'm doing. So start date is January 6th, end date equals date time 2020 11/20.date. Okay, so if I print the start date and print end date, so you can see how this looks, right? You see this date format matches the one in this from and to here, right? And so you can see how we can use a variable for the from and to here by adding over and over again. So what I'm going to do now is do while start date is less than end date, and I'll call this end date range just to give it a different value. So I'm going to say while start date is less than end date range, we're going to say end date equals start date plus time delta days equals 4. Okay, and then what I'm going to do is print, so end date range, I'll print start date and end date now. And then you'll see how this works. And I'll print this now and you'll see how this works. Okay, I'll stop it. So there's no way, the loop doesn't end yet. It just keeps going, right? So start date, while January 6th is less than November 20th, that's always going to be true, right? So we need to update start date. But you see how this starts on the Monday, adds 4 days, so it'll get up to Friday. So that's like a whole week. And then at the end of this, all we need to do is add to start date. So at the end of all of this code, we can just add, we'll do start date equals start date plus time delta days equals 7. Okay, so if I do that now, see how that works? So now you have each week by week. So I have each Monday, I add 4 days to get Monday through Friday, Monday through Friday, Monday through Friday, over and over again. So that's the week of May 11th, that's the week of May 18th, that's the week of May 25th through 29th, and so forth. So we're looping through all of those dates. Okay, and so that looks pretty good. And so I'm only going to increment this date, this start date, after all this other code runs. Okay, so I'm going to get all this code, put it in here, indent it out properly. So while start date less than 8 day end date range, okay, we're going to add 4 days to the start date, get the code for the current week, so, or get the minute bars for the current week. So I'll do from start date to end date. Okay, we're going to get the minute bars. We're going to iterate over all of the rows. Okay, just like that. We're going to do cursor execute, and then now we need the stock ID. So since we're already looping through all these symbols, and we have this stock ID dictionary that has a key of symbol where we can get the stock ID, all we have to do is do stock IDs symbol. So when we're on Apple, it'll find us the stock ID of Apple in this dictionary. And then we got this nice timestamp, open, high, low, and close. And we can run this, and it should populate all of our data. And just so we can see this while it's running, I'll just do a little print statement here to just say fetching, and I'll do an F string here so that we can make sure we can display, put variables inside of the string. So I'll do a fetching symbol for, or fetching minute bars, start date to end date for symbol. And we can kind of monitor the progress as this goes, right? And so I'll run this now, fetching minute bars for ATVI, January 6th through January 10th, January 13th through January 17th. So it's going through week by week for Activision Blizzard. And so that seems to be going pretty well. And let's make sure that it finishes all of the weeks for Activision for the year. And then it should go on to the next symbol that's in our CSV file. So we have a list of symbols that we're looping through. We have date ranges that we're incrementing. So there's an inner loop. So we start with the first symbol, then the inner loop. We go through each week for the current symbol, and then we keep adding to the start date. And so fetch it week by week. We fetch the minute bars, so we can fetch a handful or a week of minute bar data from the Alpaca REST API. And look at the one thing I messed up. I got to stop it, unfortunately. You see how I left XL and X in there? That needs to be symbol, right? We need variables for everything. So we have a symbol that's dynamic, that changes with this loop. We have start dates that we're updating dynamically. And then I'm hard coding some dates in here because I'm just going to backtest for the year. So that's fine. We're forward filling, etc. Run it one more time. Okay, so it says Activision, and we're using a different symbol each time now. So I'm going to let this run. And I'm going to let this run, and I'm going to edit out the video because I'm sure you don't want to watch all of these execute all the way through. So I'm going to stop the video and show you the results in about 10 minutes or so. All right, so I took a break for a bit, and you can see it finished downloading. Here's our QQQ CSV file, and you see it finished fetching minute bars for ZM, so all of our data should be there. If I go to my Finder, you'll see that the AppDB has grown to nearly 3 gigs in size, so pretty substantial amount of data. We only downloaded minute bars for 100 stocks for the whole year, but I think if we downloaded this for all 10,000 stocks for many years of data, this would be terabytes and terabytes of data. So I didn't want to fill up my whole hard drive. So this is about a good amount for us to test for the opening range breakout and see how it worked for the current year. If I open the SQLite database up, you'll see that in my stock price minute data, I have a bunch of rows, and you see there's nearly 30 million rows in this table. And does that number make sense? If I select star from stock price minute, where stock ID, let's just see for one of them, Apple stock I know in my database is stock ID 8961. You see that returns 300,000 rows. So I have 300,000 rows just for Apple, and we download about 100 stocks, so that makes sense that it would be about 30 million. So that data looks pretty good, and now we have some minute bar data that we can use in our backtest in the next video, and we'll backtest all of the stocks in here for every day of the year and see how opening range breakout performed and see if it even worked. And I'll also go to the GitHub page, and in the Full Stack Trading app, I'll post these couple of scripts to populate the database. And this assumes you actually have a stock table already and that you've been following along. Otherwise, it won't work. If you don't have the config file or the other stuff we have, then this isn't going to work. So, all right, so that's it for this video. Stay tuned for the next video, and we'll start talking about Backtrader. Thanks.